So welcome to online session number 27 on brazing, braze welding, soldering, and one concept regarding the heat affected zone by S.B. Patil, Assistant Professor in Mechanical Engineering Department of Jeevantrao Savan College of Engineering, Hadapsar, Pune. So we are discussing basically the course outcome number 4, that is to classify and explain the different welding processes and evaluate the welding characteristics for automotive applications. So unit number 4, that is the welding processes. So in this processes, let us see regarding the brazing process. So brazing as a production process is widely used in variety of industries, including automotive, for example, joining tubes and pipes, electrical equipments, for example, joining wires and cables, cutting tools, for example, brazing cemented carbide inserts to the shanks, and the jewelry making. So these are some of the applications of the brazing. So in addition to that, the chemical processing industry and plumbing and heating contractors join metal pipes and tubes by the brazing process. So this process is extensively used for repair and maintenance work in nearly all the industries. So let us see the different kinds of brace joints. So conventional butt joint and adaptations of the butt joint for brazing. Okay, so here you can see a brace joint. Okay, the different brace joint for different two similar or dissimilar metals. Second figure B is the scarp joint. So you can see this is joint is at the angle. Number 3 is the stepped butt joint. So you can observe here the butt joint but at the different steps. And number 4, that is increased cross section of the part at the joint. Okay, so here cross section is different at this part, cross section is different at this part, and cross section different at this part. So this particular joint is different. Okay, so all these are the brazed joints. So here also another figure of conventional lap joint. So you can see here a conventional lap joint, okay, which is done by the brazing. Okay, so if we not use brazing, we can go for the resistance welding. Yeah. Okay, so instead of resistance welding, you can go for the brazing. So this kind of brazing is the braze joint. Okay, for B, that is the cylindrical parts. So for the cylindrical parts, the brazing is done at this part. Next, sandwich parts. So you can see, so there are four parts. Part number 1, top part, bottom part, 1, 2. This is third part and fourth part, and all these parts are braced together along this different axis, and the use of sleeve to convert butt joint into a lap joint. Okay, so here this is the butt joint, and this butt joint is converted into the lap joint by using these sleeves. Okay. Here also you can see the lap joint for flat parts, lap joint for tubular parts, butt joint for flat part, butt joint for this tubular parts. Okay. Similarly, butt lap joint, or you can say the step joint for flat parts and step joint for tubular parts. So let us see the video regarding the brazing process. So here brazing is essential similar to soldering, but it gives a much stronger joint than the soldering. So for that we require a flux material, a welding torch, and the filler rod and the workpiece. So brazing is a joining of two metal pieces by using a filler metal. Mostly copper based alloy and silver based alloy are used. In brazing, the base metal of workpieces to be joined is not melted, but the filler metal is melted. The filler metal is in the form of liquid others to the base metal, and the joint is made between the two workpieces. So what is the basic difference between here the welding and the uh, brazing process? In a welding, both the base metal as well as the filler metal are going to be milled, and here in the brazing process, only the filler metal is going to melt. So this is the one of the difference between, you can say, the welding and the brazing process. Okay, moving to next point, that is the brazing has several advantages compared to the welding. So any metals can be joined, including the dissimilar metals. Certain brazing methods can be performed quickly and consistently with a high cycle rate and automated production. Then it can allow multiple joints simultaneously. Then brazing applied to join thin wall parts that cannot be welded. Okay, so if you have seen, if you remember the different kinds of welding processes, then in the resistance welding process, the thickness or the thinness of that sheet metals is up to 3 mm. So if the thinness or you can say the thickness is less than 3 mm, then we can go for the brazing process. Also, less heat and power are required than the fusion welding. Then problems with the heat affected zone in the base metal near the joint are reduced. Okay, so heat affected zone, that is a zone which is formed due to the heating at the location where we are going to weld or where we are going to braze. Okay, so definitely in welding that base metal as well as the filler metal is going to melt. So heating temperature is obviously somewhat higher. But here only the filler metal is going to melt, so heating temperature is less. Hence, the heat affected zone in the base metal near the joint is also reduced. And joint areas that are inaccessible by many welding processes can be brazed. Okay, since the capillary action draws the molten filler metal into the joint. So if you can observe here in this video that there is a capillary action, you can see that filler metal is melted and it goes into that part. Okay, and due to capillary action it comes out. So the brazing can be done to the complex geometries where welding cannot be done. Some of the disadvantages or you can say the limitations of the welding, the brazing includes the strength is generally less than that of the welded joint. Although strength of a good braze joint is greater than that of filler metal, likely to be less than that of the base metals. High service temperatures may weaken a braze joint. So generally brazing is done for the applications where there are no any high service temperatures. And the color of metal in the braze joint may not match the color of the base of the parts, base metal parts, and it can be possibility of the aesthetic disadvantage. So depending on the type of base metals braze, a number of filler metals are available. The joint obtained in a brazing by means of the diffusion of the filler metal into the base material associated with the surface alloying. So there is the diffusion of filler metal into a base metal, that is the brazing process. So copper based materials generally used for brazing ferrous materials. Okay, copper alloys having high zinc, that is more than 70% content, are not extensively used because of their brittleness. Okay, so in last year's semester subject engineering metallurgy, we have seen the phase diagram for the copper alloys. Okay, so phase diagram, in that diagram we have seen that if the if the copper and zinc, okay, where copper is the base metal, zinc is the alloying element. Okay, and if the percentage of the zinc in the copper exceeds the 70%, okay, then it goes into the gamma region, and where there is a more hardness and brittleness of that phase. Okay, so mostly the zinc percentage in a copper alloy up to 40% can be practically used. Okay, that we have already studied in last semester subject. Okay, but with the less zinc content are used for brazing of various steels. Okay, so less zinc contents means zinc content which must be less than the 40% because practically more not if we cannot go for the more than 40% of the zinc into the copper. Also, aluminum silicon filler materials are used for the brazing aluminum material. So, silver brazing makes use of silver based filler metal. Silver brazing is used to give high strength, that is tensile strength up to 900 MPa joints. Though originally used for jewelry application, the silver brazing is now extensively used in industrial applications also. So they can be used with large range of materials, but because of its high cost, it is used in only special application requiring high strength and high temperature services. Okay, so there is one session for you. Applications or products of brazing and soldering process. So I'll put this link in the chat box and the code. Okay, and I will start this session. So it is activated now. So try to write the applications or the products of brazing and soldering processes if you know. Okay, cutting tools in jewelry, industrial applications, high temperature ceramics. Okay, soldering you might have seen this process. Okay, also so you can write regarding soldering process also. That is the manufacturing of you can say the silicon chips, manufacturing of say all the computer accessories that can be a soldering processes where or the all the electronic parts. Okay, electrical parts, manufacturing of PCB. Okay, correct. Manufacturing of PCBs, soldering process is used for brazing, cutting tools, automobile component, jewelry, fire sprinkler. Okay, industrial applications, accessories. So generally, the brazing process is used where there is no any high temperature requirement for that particular application. Okay, if there is a very high temperature service application for that particular application, then we go for the welding process. Okay, if no such a things are there, then for faster production, we can go for the brazing processes because automation can be easy for brazing and the production can be taken out in a faster rate. Okay, or you can say the continuous production is possible in brazing and soldering processes rather than that for the welding. Also cost wise also it is cheaper than that of the welding process. Okay, so we have got few of these applications of product. So let us stop this now and we'll quickly move to our next session. The next point is the braze welding. So braze welding is similar to brazing where the joint is obtained by means of a filler metal. Okay, whose liquidus temperature is above 450 degrees Celsius and below the solidus temperature of the base metal. So this is somewhat confusing that the liquidus temperature. So what is the liquidus temperature? that the above which the metal will be in the liquid. So that is the 450 degrees Celsius. So if the filler material is heated and above 450 it goes into the liquid, that temperature is liquidus temperature. Okay, and below the solidus temperature of base metal. Okay, so it means here the base metal is not going to weld, so therefore it is a brazing process. Filler material is going to weld, so and hence it is a one welding process. Okay, so we can say it is a combination of brazing as well as the welding process. But in braze welding, the filler metal reaches the joint without the capillary action, since the joint gap is more. Okay, so as a result, the types of joints that can be used in a braze welding are much more varied. So what is the basic difference between the brazing process and the braze welding process? In both the process, filler material is required. Okay, in the both the process, the base metal is required. Okay, but in the brazing, the filler metal is getting melted and solid base metal is not going to heated. Okay, but in the braze welding, filler metal is melted, that is above 450, and somewhat heat is there or it is applied for the base metal but below the solidus temperature. Okay, also in brazing, the filler material uh, acts on that particular joint due to the capillary action, and here braze welding, the filler metal reaches the joint without the capillary action. So these are the some of the differences between brazing and braze welding. Okay, so typical filler metals used in braze welding are brasses with zinc up to 40%. Okay, braze welding process. So here, so this process differs from the other brazing processes in the type of joint to which it is applied. Okay, so braze welding is used for filling a more conventional weld joint such as V joint shown. Okay, so here for not taking the capillary action, we require the bigger space. Okay, if the space is very less, then due to capillary action, the filler metal comes out. That will be the brazing process. So here it is a V base metal. Okay, and where braze welding is done. So greater quantity of filler metal is deposited than in a brazing, and no capillary action occurs. So why no capillary action? Because of the bigger space available here. Okay, so in braze welding, the joint consists entirely of filler metal, and the base metal does not melt and is therefore not fused into the joint as in conventional fusion welding process. Okay, so here the base metal is not going to fuse to this joint. Or okay, so what is going to joint here, or what is exactly going to joint here, that the filler metal is going to melt and that filler metal is going to join with this base metal, but the base metal is not going to mix with this filler metal. Okay, so that is the difference between the other fusion welding processes and the braze welding process. Let us see the video regarding the braze welding process. Now we'll see the soldering process. So soldering is similar to brazing and can be defined as joining process in which filler metal with melting point, that is liquidus, not exceeding 450 degrees Celsius, okay, is melted and distributed by capillary action between the fairing surfaces of the metal parts being joined. Okay, so as in brazing, no melting of base metal occurs, but the filler metal weights and combines with the base metal to form a metallurgical bond. So that happens in the brazing. So details of soldering are similar to those of the brazing. So many of the heating methods are same. Okay. So the surfaces to be soldered must be pre-cleaned so that they are free of oxides, oils, and so on. So an approximate flux must be applied to the fairing surfaces, an appropriate flux to be applied to the fairing surfaces, and the surfaces are heated. The filler metal, which is called as a solder, is added to the joint, which distribute itself between the closely fitting parts. Okay. So in some application, the solder is pre-coated onto one or both of the surfaces. A process is called tinning, irrespective of whether the solder contains any tin. Okay, so let us see some advantages of soldering. So low energy input relative to brazing. So this is the one of the difference between the brazing, fusion welding, and the soldering. That energy input requirement for soldering is very less. Then variety of heating methods are available for soldering. Good electrical and thermal conductivity in the joint. Capability to make airtight and liquid tight seams for the containers, as we have seen in the resistance seam welding. Okay, and it is easy to repair and rework. Okay, so these are the advantages of soldering process. Disadvantages are low joint strength unless reinforced by mechanical means. Okay, so unless it is acted by any unwanted forces, the joint are not going to break. Okay, also the possible weakening or melting of the joint in elevated temperature surface. So let us see the video for the soldering process. So basically, soldering is a method of joining similar or dissimilar metals by means of filler metal whose liquidus temperature is below 450. Okay. Now let us see again the definition of the brazing process. Here you can see the definition of braze welding, that liquidus temperature is above 450 degrees Celsius. Okay, to melt the filler metal. Again, in brazing, you see the definition of brazing, that any metals can be joined, including the dissimilar metals. Okay, so what is the basic difference between the brazing or braze welding and the soldering process? Okay, so here you can see the by definition that soldering, the filler metal with melting point, that is liquidus, not exceeding the 450 degrees Celsius. Okay, so the basic difference between the soldering and the brazing or braze welding is that the filler metal heating requirement is above 450 degrees Celsius. Okay, definitely we need to melt that filler metal. And in the soldering, the temperature is below or not exceeding the 450 degrees Celsius till we are getting the melting point of that particular filler metal. Okay, so if we are using the filler metal whose melting point more than 450, then that process is called as the brazing processes. And for the other below 450, that process called as soldering processes. This is one of the difference. And the another difference, important difference is this, that is the low energy input related to the brazing and fusion welding is one of the advantages for that soldering process. So you can see, observe here different soldering joints, okay, at edges, at the lap, at the fillets, etc. Here you can see the different soldering joints. For example, say figure number A, that is a flat lock seam. Figure number B, that is bolted or riveted joint. Okay, soldering can be done. Copper pipe fittings, lap cylindrical joint, and crimping or cylindrical lap joint. Okay, so these are the different joints that can be done by soldering. PC board soldering process. On the PC board again, these are the soldering joints and different kinds of joints. Some common solder alloy compositions with their melting temperature and applications. Okay, that depend upon the what kind of filler metal is used, and that filler metal is used for which type of the applications. So for, let us say, for plumbing and heating applications, the filler metal is required tin antimony. Okay, whose approximate melting temperature is 238 degrees Celsius. So if you can observe here that approximate melting temperature for all these filler metals is below 450 degrees Celsius. Okay, that is why the term is different. It is not similar to that of the brazing. So we cannot term it as a brazing. So this is the soldering process. Okay. For example, say food containers. So tin and silver filler metal is used, which are generally non-toxic. Okay. Where 96% SN and 4% Ag. This is the approximate composition is also given. And for that melting temperature is 221 degree Celsius. So for different principal applications, different filler metals are used, which are having different compositions and melting temperatures, obviously below 450 degrees Celsius. So next session for you, that is a quiz session. I will put this link again. Same link and same event code. So join this quiz. Then we will start the quiz. Okay, out of the 38, 22 students have joined, more than 50%. So now I am starting the quiz. The quiz is started. In brazing, any metals can be joined, including dissimilar metals. Is it true or false? In brazing, any metals can be joined, including dissimilar metals. So about 90% told yes or true. So let us see the correct answer. So correct answer is true that brain brazing any metal can be joined, including dissimilar metals. Next question, dash dash based materials are generally used for brazing ferrous materials. For ferrous materials. Okay, so let us see the answer. So answer is the copper. So copper based materials are generally used for the brazing ferrous material. Okay, we had the discussion on that copper zinc alloy also. That zinc percentage more than 70% cannot be used, up to 40% can be used. Surfaces to be soldered must be pre-cleaned so they are free of oxides and oils. Is it true or false? Surfaces to be soldered must be pre-cleaned so they are free of oxides, oils. The correct answer is true. Now moving to the last question. This is the method of joining the similar or dissimilar metals by filler metal whose lowest temperature below 450 degrees Celsius. Okay, so it is a 450 degrees Celsius, not 4500. So the correct answer is soldering. Yes, it is correct. So below 450 means that is the soldering process. Above 450 is the braze welding, okay, or the you can say the brazing process. So Ruturaj, Fardin, Balaji, Rishi, Karthik, Bhushan, Satyam, Sufia, most of you have given the correct answers. Okay. Total 10 students have given all four of the four correct answers. Okay, so let us quickly move to the next session, that is the heat affected zone. So during the arc and gas welding processes, the workpieces to be joined and the filler material, that is welding rod, are heated to a sufficiently higher temperature to cause both to melt. Okay, so upon solidification, what happens? The filler material forms a fusion joint between the workpieces. Okay, that is why we go for the welding process. So thus there is a region adjacent to the weld that may have experienced microstructural and property alterations. And this region is termed the heat affected zone, sometimes abbreviated as a HAG, okay, or HAZ. Okay, so we might have studied this part in a last semester subject also in sensitization of stainless steel. Okay, or you can say the weld decay of steel. So there also we have studied this heat affected zone. Okay, so possible alterations include the following. If the workpiece material was previously cold work, this heat affected zone may have experienced crystallization, so recrystallization, and the grain growth, and thus a diminishment of strength, hardness, and toughness. Okay, so the HAG for the situation is represented schematically in figure. We'll see that figure. And upon cooling, the second alteration may be the residual stresses may form in the region that weaken the joint. So let us see here in the figure that say this is a workpiece 1 and this is a workpiece 2. So both the workpieces are getting welded either fusion welding, gas welding, or any other process. So they are getting welded here. Okay, so this welding is done at the higher temperature. Due to that, what happens when the welding is top? When the welding is top, the heat is transforming towards this section from high temperature. Say this is the high temperature at this point to say low temperature. Okay, heat is going to transform towards this from high temperature, okay, towards the say low temperature. Okay, so this is the movement of the heat or movement of the temperature. So if there are some regions like this, if there are some regions, suppose this is one of the region and this is second region. Okay, so if these regions are cold work previously, if these regions are cold work, then due to the transfer of heat, due to the transfer of heat from high to low, the heat transfer through this part, so that some alterations are possible in this region. Okay, some alterations are possible in this region, or you can say some non-required or non-essential alterations may happen in this region. Okay, so this is the possible alterations that can be found in heat affected zone. Okay, so this is the heat affected zone. You can see here, this is the heat affected zone. Okay, this part is the heat affected zone. Okay, where in this area there are chances of possibility of the changes of the microstructure, or you can say this kind of parts may lose their strength, may lose their toughness, may lose their hardness. So property are going to alter due to the movement of this heat from high to low. Okay, now for steels, what happens? The material in this zone may have been heated to temperature sufficiently high so as to form the austenite. Okay, so upon cooling to room temperature, microstructural products that form depend on the cooling rate and the alloy composition. So for plain carbon steel, normally perlite and proetectoid phase will be present. However, for alloy steels, one microstructural product may be martensite, which is ordinarily undesirable because it is so brittle. Okay, so if you consider steel here, then in this part where the heat affected zone is there, okay, there are chances of formation of the martensitic phase, due to which it makes this part brittle. Okay. Sometimes stainless steels may be sensitized during the welding, which renders them susceptible to intergranular corrosion. So we have seen this sensitization of stainless steel part. So in this sensitization of stainless steel, there may be a formation of corrosion, and that kind of corrosion is called as intergranular corrosion. Okay, or you can say that corrosion occurs through the grains or through the grain boundaries. So that is the intergranular corrosion. So here you can see the cross section of typical fusion welded joint. Figure A, that is the principal zones in the joint. So you can see here this is the fusion zone, and this one is the heat affected zone, and this one is the unaffected base metal. Okay, and this is the weld interface. In second, a typical grain structure is there. So columnar grains in a fusion zone, coarse grain in a HAG near weld surface, finer grains in HAG away from weld surface, and original cold work grains are here. Okay, so as the heat passes from this particular point towards the next point, okay, or from the center to this part, okay, so let me show you by drawing. As the heat passes here, from here it is the maximum heat, and it passes from high to low. Okay, so we are getting the in the intermediate temperatures we are getting finer grains, so we are getting the correct properties here. Originally cold work grains, so no effect on the heat, but here as the temperature range is in between say 500 to 800, for example for the steels, or for let us say for stainless steels, if the temperature range is in between 500 to 800, then the coarse grains are observed in that heat affected zone. Okay, and due to which there are chances of alterations of the properties. So thank you very much for the today's session. Let me stop the recording.